Did you hear the banger? You heard that banger of a song right there? Damn. Damn. See you last. Oh, that's cool. Cool. Sweet. Negative. I am a meat popsicle. Okay. Work time? Neat popsicle? It's neat because it's frozen with alcohols. Look, guys, it's actually not freaking warm in here today. But it is the beginning of the day. I want to show the temperature right at the beginning of the stream to show you guys how hot it gets in here. Watch. By the time Space News happens, or we go back to playing Kerbal, that number is going to be way higher. Now here, I'll show it and see for everybody else. It's comfortable 22C, 73 Fahrenheit. Comfortable. It ain't about to be comfortable. It's like 35 outside. Yeah. 90C. Or not 90C, we'd be dead. 90F. Sorry. Need more coffee. Pretty indicative. God, I love coffee. Oh, it's so good. What? I'm loading up Kerbal. Stop judging me. Jeez. I can never learn to like coffee. Lol Dog. Okay, so here's how it happened with me. I used to drink Red Bull all the time. You remember that? Like 4 Red Bulls a day. Not good. And I went to the doctor one time, and she's like, your heart rate is like stroke victim heart rate. Are you okay? And I'm like, yeah, I feel fine. And she's like, EJ, how much Red Bull did you have yesterday? I'm like, 4 cans? And she goes, EJ, how much Red Bull do you have a week? And I'm like, a case? She's like, a case a week. I'm like, yeah. She's like, yeah, you need to stop doing that or you're going to die. I'm like, huh. My doctor and I have a very candid relationship. She's like, yeah, you got to stop doing that. So I started drinking coffee to replace Red Bull. And originally I was like, it doesn't really taste very good. It kind of tastes like chalk. But it's like one of those things, you keep drinking it and eventually it becomes really... dude, it's delicious. It's delicious. Yeah, something like that, Tessa. In like 2017, I'd go to the store every day and buy a 4-pack of Red Bull and finish it. Yeah, that's not good. That's probably not a good thing. Doctor was probably right in that regard. Hey, Reagan. Yeah. Yeah, it's the same thing with beer. Yeah. I never used to like the taste of beer. Now beer is extremely refreshing. I will not eat... If I have the opportunity to eat, like, steak, I will have a beer with my steak. Because it's delicious. Especially Guinness. Which also kind of just tastes like coffee. Go figure. Jiu-jitsu makes your ribs go, ow. Ew! Oh, no. No, I'm telling you, it's an acquired taste. Beer tastes like soda for me now. It's like, you have a Coke or an orange soda or Sprite or something. It's delicious. That's what beer tastes like. If you keep drinking it, it ends up tasting like that. It's delicious. You're really turning into a real American. Hey, Boxy, everybody said be yourself, alright? And for the longest time, dude, like when I was in high school, I was afraid to be myself because I was worried about being a stupid stereotype. And it turns out that I'm just, you know, if I'm going to be myself, I'm just going to be a freaking stereotype, dude. Like, oh, well. I mean, look at me. I like freaking rockets, V8s, football, sports. I like steak and beer. And, like, what? I have a big walking stereotype. I don't care. I don't care. I really don't. It is what it is, man. You know? Secretly becoming an alcoholic? I don't drink beer a lot, dude. I don't need to drink beer. It tastes good, but I don't need to drink it all the time. Wait, you walk? Ooh. Ooh. Stings the nostrils. It's quite pungent. Yeah, okay. Dude, I like what I like, man. Like, I can't change that. You know what I'm saying? I don't know what people want me to do. So, yeah, it is what it is. Alright, MLV, let's go. How's the morning been? It's alright, Cloudy, how are you? Nice ESA video for break time. 5-minute loop, make us cultured. Is this the Vega launch loop stuff? Oh, yeah. Yeah. Yeah, we saw some of this in a cut video the other day, Foz. What do you think of my capsule design? What do you think of my capsule design percentage? Left to right timeline-wise. Added the docking port to the smaller one will get more science. If it does what you need it to do, man, then it's a good design. Nuclear, if you're asking me, like, how it looks great. Sneaky, today is going to be a day. Today is indeed going to be a day. Try a dry cider with steak. Especially if you marinated some cider, you got a few hours too. I've done that, Tessa. Yeah, that's good. That's good, man. Oh, yeah. No, dude. You dropped all your fresh Wendy's fries. We need some F's in the chat. We need some F's in the chat. That is just a damn shame. You working on the Jeep, Sawyer? Sawyer, tell Assmaster how cool Cherokee XJs are. Assmaster, listen to Sawyer. He has one. Dude, I still got that link up, man. Place taps for the fries. Yes. They were the crispiest. Okay. Alright. So, we were working on the Yeetus Deletus, and I'll tell you, check this out, guys. You know what I was thinking? Just when we were playing KSP yesterday. We were Come on, I got a cough drop in my mouth. Really? Why am I coughing? Is there going to be a drag penalty? Okay, Nuclear, hold on. I gotta go look at the pictures. And Sawyer, good work on the Jeep. Looks good. Cherokee XJ. S-Master. I'm telling you, that thing is a monster. It is a cool truck. Alright, let's see. What's on your mind, big guy? Is there going to be a drag penalty on top because of the radiators and the RCS balls sticking out? Balls? Yeah. So, Nuclear, what Rocket Guy... Actually, Rocket Guy is the one that came up with this idea. And I used it for my capsules, too. The APS back in the day. So, the radiators are all fine and dandy. But you know what you should do? Put a fairing up here. I know that that's going to be difficult with, like, these guys here. But with this big boy capsule, put a fairing up here, like a fairing plate, and then make a fairing that goes backwards, and then have it go like in to the module, and then make the fairing go out, and then have that be your service module. The reason is because fairings don't like flying backwards. I've just noticed that they really don't like flying backwards. I noticed it, and Rocket Guy's the one that proved it. If you make the fairing backwards, all the drag gets imparted on the vehicle up here, and the capsule wants to fly backwards, and it stays perfectly balanced through, as long as you keep your center of mass forward, right? So long story short, yeah, the RCS balls, those aren't going to cause drag. They're physics-less, remember. The tanks, though, yeah, absolutely. Easiest way to do that is to put those inside of a fairing, and then maybe you could attach radiators to the outside of the fairing or something. That's what I would do if I was going to make a capsule. And I think we should make a capsule sooner rather than later for the MLV, but yeah. Random thought, could you use the YITA stuff to somehow drive a trebuchet? Yeah, that's not the type of actuation that you need for a trebuchet, Sebi. But what I was going to tell you guys is... Okay, Sebi, let me finish with nuclear first. Okay, so hey Roro, what's going on? So, listen, alright, look, everybody hates drag. Everybody's like, oh, drag is the enemy. Drag is bad, drag is bad, drag is bad. Like, if my aircraft makes drag, I want to make it make the least amount of drag. No. That's not how that works. Drag is just the thing that happens. It's a thing that happens. Think of it like a screwdriver in your tool belt. You make the vehicle make drag where you want it to make drag. Now, nuclear, think about it like this. Those will make drag. Are these little RCS tanks and RCS balls going to overpower anything on the vehicle on the way up? The radiators have the potential. They create a lot of body lift. Right? So, like, if you have a rocket behind this and you put some fins on the bottom, the force that's created by the moment from the fins will easily overpower this, and your rocket will fly just fine. Right? Now, on the way down, the drag made from all this stuff will work very well in your favor. But you got to make sure, this is what I mean about making a fairing. You got to make sure that the moment from these right here doesn't overpower the moment from these radiators here. These radiators, got them. Think about it. If these are generating more lift than those radiators out back, right? Your capsule's gonna fly crooked through re-entry. You don't want that. Not intentionally, at least, right? That's not a good idea, because then your capsule can flip over and stuff, and then it can go nose cone first like a nuke, and that doesn't end well. You want to keep the center of mass on your capsule as close as you can to the heat shield, and you want to make drag up here. That's what it's supposed to do. That's what it's designed to do. It's the same thing with like the shuttle. The shuttle is just a capsule that's plane shaped. I'm not even kidding, dude. So, look at this footage from a hypersonic test tunnel. Look, there's the heat shield. You see it? It's even capsule shaped if you look at it from the side. It's concave. But it's concave around the center of mass. So, what does that mean? So, if you look at like a regular capsule, like this, right? Look at a regular capsule has its heat shield, right? Center of mass is like right here. Right? Pretty straightforward stuff. The heat shield is the thickest around the center of mass. If you look at the shuttle, right? So, let's do this, right? Right, you got your shuttle. Right, like that. If you look at the heat shield on the shuttle, well, where's the shuttle center of mass? It's riding right around here. If you look at the shuttle center of mass, it's literally just a capsule. Or the TPS resembles a heat shield that looks like this.
Hey, can I throw away your two big things of Swedish fish?
Yeah, go ahead. So it's the thickest right around the center of mass. Now keep in mind the shuttle is not using an ablator heat shield, it's tiles. But if you look at the shuttle from the bottom, it is concave like that. Or convex, excuse me. But the thickest part is right around, and this includes with the body flap, the thickest part is right around there, and then it goes up like that. Look at any picture of the shuttle. It gets really thick right there. It's the same shape. And the shuttle is just designed to make drag, just like the capsule is. That's why the back of the shuttle, and that's why I drew it this way, the back of the shuttle's flat. And then it has those big honking wings on the side, right? And it's designed to make drag. That's what it's supposed to do. It's a re-entry vehicle. Remember that. That's really important to understand. It's really important to understand that drag isn't the enemy all the time. The shuttle is intentionally designed to make drag because it's a re-entry vehicle. If it wasn't a re-entry vehicle, they would make it so it wouldn't make a lot of drag, and it'd be a nuclear re-entry vehicle, and that would come down and hit something, right? That's because the shuttle is not aerodynamic, but that's by design. That's why it flies like trash down here, because it's designed to slow down going Mach 10. It's designed to create insane amounts of drag and only work just at the last second to touch down on the runway correctly. So, nuclear, just think about it. Think about what forces are going to be made by those RCS tanks, where that force is going to be imparted on your vehicle, and the moment that force will have. That's important stuff to understand, especially when you're making a vehicle. You really gotta. The way I design vehicles is I don't just intend for it to make drag in one spot. Like I don't try to just minimize drag. I said that wrong. I don't just try to minimize drag. I try to make the drag go to one area with the hierarchy. That's why I said build a backwards fairing. But if this works, and if these capsules work and they do what you want them to do, then it doesn't matter. Because it's, at the end of the day, engineering is subject to a rule set. There's two types of rule sets. There's the laws of physics, obviously, and then there's your stakeholder expectations. Every time you build something in Kerbal, you basically should come up with a rule set governing what the vehicle should do. It's nuclear. It's what I always say. What are you trying to do? What are you trying to do? If the thing does what you want it to do, then it's a good design. Nice, Elphys. I didn't have time to draw that model to scale or to paint it. Nope. So just consider that kind of stuff, dude. That's important to understand. Drag is not your enemy. In fact, with a re-entry vehicle, it's what you want. And if your capsule's going to fly heat shield first, you'd want drag at the back of the vehicle, wouldn't you? Just something to consider. So, you know what was crazy? Yesterday, Tessa, we figured out that this thing is making 21 meganewtons. I just want to point out that hybrid tech robotics with the Kraken, so like the robotics with the Kraken tech, with the Kraken tech backing it up, held up 21 meganewtons of force, and then some. I just want to point that out. This freaking thing held up. It held up. The hinge withstood 20,000 kilonewtons before it even bothered breaking. That's pretty good. When is the launch? About an hour. 2,000 tons of thrust. Tessa, that's pretty damn strong. Dude, this drive, we broke the mold with this drive. This is the one, man. Just pushing around Grissom. This thing pushed Grissom at 10 Gs? And Tessa, it's something that I'm kind of figuring out. The hybrid tech does help reinforce the drive. It definitely helps. But really what reinforces the drive is basically doing, if you think like 4-link suspension, you just have to, everything has to be located correctly and it can't move. So you just basically got to strut everything to everything. Not necessarily everything to everything. You got to be strategic about it. But yeah, pretty crazy, right? There's a new aircraft that plans to minimize drag. It flies mostly in laminar flow, and it's a pusher with a red piston pusher, and it's 20% of the cost of executive jets because of it. Interesting. Yeah, we broke the game. Yeah, that's right. Alright, so that's what we were working on with those drives yesterday. We got to get back over here. The twin crane system. Yeah, we saved some yeet stick stuff in the wrong folder. Instead of doing that here, I'm gonna go in here like this and just go here. I don't know what we should do with these. My name is Jeff!
My name is Jeff!
Is there any sort of quirk of the KSP mechanics that could allow you to create an inertial damper? Inertial dampeners. Nice. Phrase inertial damper is actually misused in science fiction to describe a device that negates inertia and removes it from surrounding mass. It is more properly described as inertia negation. Yeah, Tessa, we'll get rid of them. Alright. Cool. Found it. The plane is Celera by Auto Aviation. Alright, hold on. Hang on. First thing, I gotta bring up cam. We gotta bring up the temperature monitor. Second thing, Celera Auto. Cool. Damn, boy! She thick! Huh. So what is this thing supposed to do? Fly. Yes. I gotta... So Sasquatch is a newer aircraft that plans to minimize drag. It flies mostly in laminar flow, and it's a pusher with a red piston pusher, and it's 20% the cost of his active jest because of it. Super low drag. Yeah, I see. You're not gonna get any, yeah, this is not gonna make much turbulent air. Yeah, I see what it's doing. Yeah. Cool. Yeah. If you're not making turbulent air, you can afford to make a pusher prop. That's the thing about pushers. If you don't have laminar flow going into the propeller, it's not going to end very well. And that one, yeah, I can definitely see it. The intakes are up top and they're scooping up the laminar flow coming off the fuselage. Cool. That's pretty cool, Sasquatch. Yeah, I see it. Yeah, I see what that's doing. That's pretty neat. teardrop, man. The whole thing, if you look at the side, is almost shaped like an airfoil. I mean, Sasquatch, I'm inevitably going to mention the X-48. Inevitably. I like that idea. But I think Boeing had it right with the X-48. The blended wing. No turbulence. Super fuel efficient, and it generates insane amounts of lift. I mean, instead of just making the fuselage airfoil, why don't you make the whole plane? Giant airfoil, blended wing. I love that design. I think that thing is sweet. Airliners should be made like this. These things make no drag. They can fly higher, they're super fuel efficient, and they can fly further because of it. And they can carry more people, because the whole thing is a frigging wing. People would sit in rows, like, dude, there's like, this isn't, people sit in rows like here, 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 and here. This is not even a narrow body. This is not even a wide body. It's, I mean, keep in mind it's just a prototype, but yeah, man. Like the Fallout planes. Kind of, yeah. Yeah, gate space, though. That is a problem. Yeah. Yeah, Gary, yeah, good call. It's such a good design, though. That thing makes, like, no drag. Because, remember, this thing makes no drag because it's not a re-entry vehicle. It's designed to fly in the subsonic regime, and when you're flying subsonic, you really don't want to make a lot of drag. If you're flying anywhere subsonic, supersonic, hypersonic, you don't want to make drag. Right? That's the intended purpose. This thing is designed to slip through the air like a bird. SpaceX audio is online. Okay. I'm going to turn the mission control audio on there. Thank you very much. Okay, so let's get back over here. No, we never heard anything about it, Chris, but they're ready to go again, so. We should really test to make sure that this type of hold-down mechanism works correctly. Yeah, I know, Sneaky. It's a weird problem to have. I'm really having trouble managing my time with KSP because of all these rocket launches. Like, I mean, I'm not complaining, right? Like, I'm not complaining. Okay, so that's where I left off, making those things. Why can't I hold all these rocket launches? $79 tons of fun. Okay. The grip pad holder is... I'm not sure that that's a good idea now that I'm thinking about it. I don't want... Well, I kind of do want this to stick to it, but I don't want the trailer to go up when we try to pull the vehicle. Huh. 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 What's up, S? Claw cradle? Tessa, what? Dude, claws are terrible. Why would you ever want to use those? They're super imprecise compared to a docking port with some Kraken tech. Why would you do that? Hello, serious potato boy. Huh. Huh. Yes, Ben. Why not just make it all one vehicle and launch it on the trailer? No, not the in-game claw. A robotic claw. Staring at photos of the XJ and eagerly waiting for my boss to run my bonus through. Nice. Nice. See, S, here's... I didn't want to type this all out when I was talking to you yesterday. But here's how this works. Buy one car, right? Buy one car. Make it as reliable as possible. For, like I said, for me, that's the Mustang. I do not screw with the Mustang. I do the routine maintenance on it, and that's it. I don't modify it. I just take care of it. I baby the thing. I don't drive it in the snow very much. I take care of it, and it takes care of me. Okay? That thing's never failed me. Ever. Alright? Get a reliable daily. And then go and buy the fun stuff. But you should always have a reliable daily. Straight up. Yeah. Yeah. Yes. Exactly. Yes. Yeah. So once you have a Jeep and the Jeep works and the Jeep's great and the Jeep runs and you know, I mean, it's got the AMC 242 in it. That motor doesn't break. You have to really try to break that engine, and that's not a challenge. Like, it'll take care of you. It's a great motor. It's not the most efficient motor around, but it won't break. I've seen those 4-liter Jeep engines run with no oil. And yeah, that's like first-hand experience, because my sister had one of those things, right? And I remember when she went off to college, I drove the Jeep around in the winter, because I didn't want to mess up my car. So I drove the Jeep around in the winter, right? And I remember when my sister left, right? I was looking at it, I'm like, oh man, this thing needs to be cleaned up and stuff, blah, 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 blah. And I was like, when's the last time you changed the oil? And she's like, I need to do that? And I'm like, oh no. I checked the dipstick, like a drop of oil. I'm like, uh-oh. Yeah, I'm like, uh-oh. So, I changed the oil. Motor was fine. Never had a problem. I drove that thing all through that winter. And then a little bit longer. Because like I said, my sister went off to college. I drove that Jeep around for a long time. Never had a problem. The motor had no oil in it. I don't know how that's possible. What Jeep? Is a Cherokee XJ, Adino signed. Cherokee XJ, guys. It was a nice Cherokee, too. She didn't take care of it. It was nice, dude. Cherokee XJ 4x4 Limited. It was a 2001. It had all the bells and whistles for that year. It had everything. 4x4. It had the nice transfer case in it. It had Dana's. No, what was the axles that came in that truck? Hang on. I think it was Dana 44s, but I could be wrong. Now I have to look this up. We'll get to the MLV in a moment.
I have a couple questions.
I have a couple answers.
I don't know if you do. Question 1 is, when did we get these?
John gave it to us.
Question 2 is...
Skittles don't expire.
Yeah, they say August 22nd. So the answer to, can I throw them out, is probably no, aren't
Those
they?
were a present.
Okay, so
okay, keep one package. We have to keep one package. Those
okay.
were a gift from a viewer.
Okay.
They are very endearing to me.
Okay.
I'm not even kidding.
That's fair. That's fair. Sneaky, thank you. I'm glad you like my shirt. My parents got it for me, of all things.
Those are my Skittles, damn it! Those are my Skittles, damn it! Alright. Let me see. Let's take a look. Yeah, see? The 4-liter, the 242 engine. That thing is impossible to destroy. Sawyer, I don't know how you did it. If Sawyer's here. There's a viewer that broke one of these, and I don't know how it's possible. That's the only time I've ever heard of one of these engines breaking. Let's see. Where is it? So, see these hooked up ones from the 2000s that have like all the nice painted trim and stuff? That's what the truck looked like, only it was fleet white. Dude, these things were toe up, man. They're really good. Yeah, see? Okay. Here. So 84, it was a Dana 30. There you go. It had a Dana 30 in the front. Look, high pinion of reverse cut gear, 27 spline. Nice. And then it had a 40, 30, no. 35 in the back. Dude, this thing was hooked up. It was money. Yeah, they're freaking mint, dude. They're such good trucks. It's basic as just, like, I'm not going to lie to you. The interior of those things are very Spartan. They're very basic. But that thing will not let you down. I guarantee it. And if it does, you can fix it. It was an automatic Journey. Yeah, it was an auto. It had some junk 4-speed in it. But the transmission, dude, like I say some junk 4-speed, the transmission never let me down. Dude, I drove that truck through multiple winters. And it worked. Dude, it is a monster in the snow. It just went through the snow. It was like driving on nothing. It was like driving on pavement. It just went right through the snow. No problem. It was my sister's car, Tessa. She doesn't know what a stick shift is.
Discovery, go and throttle up.
Ugh, damn it, S. This is why I don't do this, because now I want a Jeep. I can't afford it. I don't have any money. Canadian, what's up, dude? 22 months. Get an old Wagoneer. Ugh! Stop this! Stop it! You're killing me, guys! I don't have any cash to do this. I just bought a house, damn it. But if I am going to get a Jeep, it's going to be that. An M715. Because tremors. Nah, Dino, I'm a little bit old school when it comes to my Jeeps. M715. Now that's a Jeep. If you get a Jeep, it would help you move. Get a Wrangler. Wranglers are good too.
Discovery,
Wranglers are good. Blue converted a Prime sub to Tier 1? Yes! Thank you. Awesome. Yeah, M715s are cool. Then I was going to say there's a ton of them out there because they're mil surplus. People don't just paint these things this way. These things are cool, man. They came with a 24-volt system because military power. Military power through all vehicles gets standardized. So this thing has a 24-volt system if you buy Army surplus, which is really, really cool. Yeah, mil surplus, like, yeah, whole 24-volt system. The thing's built like EMP proof and stuff. And don't get me wrong, I'm no prepper or anything, but that truck ain't gonna let you down because it's literally designed to get messed up on the battlefield. So you know it ain't gonna let you down. But yeah, there was a lot of these mil surplus in the 70s, in the 80s. There ain't a lot anymore. There ain't much anymore. But if this truck looks familiar, if you've played GTA 5, Trevor's truck is an M715. Yeah, just for anybody that wants to know. The Canis Bodie. Should be a 6-month or 2. I don't know why it didn't add that. Oh, a 6-monther, man? Yeah, you're too good to me. You're too good to me. Speaking of preppers, did you see that New York put out a PSA for a nuclear attack? Yeah, Dino Sign. M715s, 24-volt, dude. Really freaking cool. Just like if you bought a surplus Humvee nowadays. 24-volt systems. Why is it 24-volt? Why is it 24-volt? For the people that don't understand that. So, a regular automobile, your car, my car, the truck, my 59, the Cornet, whatever, they're a 12-volt system. Now, the reason why that truck has a 24-volt system is because the military wants to standardize the power. Other vehicles run on 24 volts. A tank, a truck, a fuel vehicle, airplanes, they all run on 24 volt. You standardize the power, so it makes it easier. The electrical logistics get easier. They figured that out in the 50s. You standardize power sources, so you don't have to have like 30 generators to charge the batteries on 30 different vehicles. You just have one, and it charges everything. If you need to charge batteries. These things generate their own power, obviously. Yeah, because in the like I said, in the military, stuff has to be simple. Because think about the stakeholder expectation if you're making like a firearm. It's got to be simple. Because when you're on the battlefield, that firearm's going to get dragged through the mud. It's going to get banged up. It has to be simple. Right? Same with the vehicles. Same with the gear, the boots, everything. It all has to be that way. And I think that's kind of cool. Because you know it's not going to let you down. Yes, please don't cause panic. The department released a short video titled Nuclear Preparedness PSA on Monday, but not much else was shared other than the NYC Emergency Management shares important steps for New Yorkers to follow if a nuclear attack occurs. Laughs in G36. Sebi, that's a nice gun. It's a nice gun, but it's like a Mercedes. If it works great until the thing doesn't work no more, and then you're gonna have a big problem. Me, personally, if we're gonna talk German firearms, that's my guy right there. That is Chad tier design. The way this whole gas blowback system works is, well, not really. It's not a gas blowback. It doesn't have a gas block on it. The way this system works is frankly ingenious. Correct. That's why we're replacing it. It's a piece. The internals are great. The rotating bolt in the G36 was fantastic. It's the rest of the gun that sucks. The rest of the gun's a piece of junk. I'll take a G3 over a G36. Thank you very much. I get it. The G3 is heavier. I'm a big guy. I can move it around. It's fine. I mean, yes, it's very interesting. Like, there's really not much to nuclear attack. If you see the flash, that's it. You're pretty screwed. Like, I'm not gonna lie to you. The way nuclear weapons work nowadays with impact, like multiple impact reentry vehicles, and don't get me wrong, I say nowadays, this hasn't been a thing. This has been a thing for a while. The way that all works is, I mean, if you're near a city, you're basically gone. Like, I'm not trying to cause panic. Like, but if through some miraculous way you survive, don't go outside. Do not go outside for like a week, because the fallout will kill you. And then it's gonna rain, and it's gonna rain nuclear raindrops. Don't do that. Don't go outside. Like, that's it. That's it. You need enough to stay underground or inside of a building or something for a long time, and hopefully it has HEPA filters. That's really it. That's all you got to know. Ducking cover does nothing. And they kept saying over and over that it wasn't because of Russia. If you see the flash, just smile and wait for the camera click, Demon. You're about to get Sarah-Conned. Yeah, you gotta wait a month. You gotta wait until so like when a nuclear blast happens, it shoots all that nuclear fallout and radioactive particulates all up in the air after it goes off. So after the big blast, you get a Chernobyl. Understand? These radioactive particulates like cesium, what's the other ones? There's like, why am I forgetting all this? I should know this. Cesium is the big one. There's other ones. It depends on what the nuclear weapon is made out of. But all these, it's radioactive dust. Think about it like dust in your house, right? What does dust do? It gets everywhere. It gets everywhere, and it sticks to things because static electricity. So you get that fallout that happens after. And don't get me wrong, it's not as bad as like a nuclear power plant going off. But I would say I would rather have a nuclear power plant go off than a nuclear explosion. Keep in mind, power plant and explosive are two different things. Strontium. Yeah, I think it really depends on what nuclear fuel you're using. But, long story short, the nuclear blast throws emissions everywhere, and that screws with the local climate pretty bad. All those particulates get stuck in clouds and stuff, and then it rains them down on you. That's like nuclear fallout. That's what all that is. It's not rough, it just gets everywhere. But it's coarse, rough, and it gets everywhere. No, yeah, that's the general gist of it. If you survive the big part at the beginning, just stay inside and wear a mask or something. But, yeah. You gotta be careful with that stuff, man. Alright, so over here, if you guys notice, I have a checkerboard right here. I don't want to talk about dooming anymore. That's not fun. Right there. That's the center of mass of the vehicle. So we have to design our truck kind of around that. Have you seen I Do Cars on YouTube in his broken engine disassembly video? I Do Cars? Which one, Scrivy? What's up, AP?
Rock, this is LB on countdown 1.
Hold on.
This is Rock.
Locking in. Range is ready.
Range is ready.
Copy.
Range is green for the Falcon 9 launch. This seems like a good channel, dude. Wow, this guy does all kinds of stuff. Here, I'll show you guys. I'll show you guys what I'm looking at. I just always have to kind of pre-screen the channel just to be sure. Oh. Yeah, that Ford. Yeah, you see those holes right there on the thumbnail? Yeah, those. That's not good. I see an LS right there. 6.2. That thing's junk. Hey, like the one that he's working on is obviously junk. That wasn't a good design. Oh wow, this guy does all kinds of stuff. That's pretty cool. I like that. I like that. No, like even though I'm a huge Ford guy, honestly, dudes, I'll work on whatever. I don't care. I like wrenching on cars. This guy just messes with everything. Oh, 6.8, dude. All right, hold on. Let me just peep this motor real quick.
I get a ton of requests for various engines that you all, my viewers, would like to see me take apart
6.8,
on
baby.
video.
V10.
And unfortunately, some of those engines just aren't available in North America, or perhaps they're extremely late model or exotic.
Wow.
And I just haven't found a good source.
AP, this
to get
guy
hold of
engines, dude. Look at this.
For that type of vehicle.
It's got to be a rebuild shop.
But when the same engines are mentioned over and over again, I try to pay attention. And I make some calls, send some emails, and I see what I can find. And that is why today's teardown is on a Ford 6.8 liter V10, namely a 3-valve variant found in the 2005 to 2010 Ford Super Duty,
Those
the
motors are
F-250 and
cool.
larger trucks. And I've driven.
So that is a 6.8 V10. It's the motor from my Mustang with 2 more cylinders attached to the front. Yeah, seriously. Ford used it as a truck engine. It's basically just an extended V8. That's all it is. It's really cool, actually.
Driven these trucks. They make 360 horsepower, 460 foot-pounds of torque.
Yeah.
They run really good when they run. I mean, really good when they run. Now, this may be the very first 3-valve
that's
V10
a
I've had in the
chunker,
shop, but I
dude.
am
Look at the
used to working
exhaust
on
manifold.
the 3-valve engines. We have a 5.4-liter V8 in our 2008 F350.
Oh, it'll fit, Tessa. It'll fit.
I used to haul a lot of these core engines back here. I bought that truck pretty cheap about a decade ago with a
AP, look at all.
Countdown 1. The propellant load control is complete, and we are go for propellant load.
Prop load is go on the Falcon 9. Look at all the LSs back there. Oh, homeboy's got 15 LSs on the wall right there.
Primary countdown now.
you guessed it, bad engine, and it's been good ever since it's
Yeah,
been fixed.
you
except
saw
for
what I
can
saw.
filters. But we're not going to talk about that truck. We're going to talk about this core, and this is supposed to be a non-rebuildable core, and it took me just a few seconds to realize why. This particular engine has
Oh, no, I can't show that gore on stream. Oh, that's not safe for work. Rodney's saying hello. It's like when you watch like a gross video on the internet. You're like, it's disgusting, and you know it's disgusting, but you can't look away. So V8 F2 V8 250 when? No. Tessa, I have plans. Don't you worry. I have plans. I'm not get Tessa. That truck, the 250. I want to keep the matching numbers motor, and you can do insane things with 351s. 351 Windsor's a good engine. You could get it. You could punch it out to 406 cubic inches, which is 6.2, 6.4, somewhere around there. 6.4 liter. You can punch them out, and then you can turbo them or supercharge them, and they make auto sequencer is started on the Falcon 9. You can make insane amounts of power with those, but if I was going to swap motors for that truck, in the truck, I'd put a 460 in it. Ford, in those trucks, so it'll bolt in. Ford made a 460 cubic inch motor. Now, for Europeans and everybody else that doesn't understand what cubic inches are, that's like 7.5 liters. How much torque do you want to make? Yes. 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 Hey, Neko, what's going on? Is it an iron block? Cast iron. It's a cast iron 351. AP, it's not a Clevo. You guys have... They made Clevos in Australia. Ford stuck with the Windsor motor in the States. So, it is a punched out 302 or a 5 liter that would have came in... like, actually, like XA Falcons, stuff like that. Like XA Falcons, like old school. They never stopped making that motor over here. 17 minutes in on that video, it pulls the head. I like this channel, Scribby. I'm gonna follow this dude. Thanks for the recommendation. I always, dude. This is what I do after streams. I read about this stuff and space stuff, and that's it. I'll sub to that channel, absolutely. Why not V24? Can you link up that channel? It's called I Do Cars. Yeah, sure. Here, I got you. That's good recommendation. Yeah, that's cool. But yeah, Tessa, if we're putting in there, put the 460 in. You put the 460, port the heads, you'll make like... How much torque do you want to make? Yes, all the torque. Or we could go 7.3 IDI, or we could go 24 valve Cummins. 24 valve Cummins would... If a 460 is making all the torque, Cummins is like max Q torque, if you catch my drift. Yeah. Plaid torque. Yep. I want to see your face at the head reveal. Okay, let's make sure we don't get into reaction video stuff too much, okay? Yep, that's just a modular engine.
All right. Let's see what we've got.
I want to mute it. Okay. Yeah. See, this all looks good. This looks good. That's okay. That's just some coolant from the head in the piston. This one's got a little bit of carbon scoring, but the piston is not centered in the bore, and whatever the hell happened here was not ideal. Yeah, you can see the piston rings, and the piston is in the bore, okay? So, before I even listen, I'm wondering if I'm going to get this right. That piston's okay. That one's fine. This one just has a little bit of coolant in it. However, if that's oil, then we got a big problem. There's a big problem there if that's oil. I can't really tell. That's junk, and there's literally no piston in this bore. So, Scrivy, what probably happened here is that it snapped a connecting rod. It snapped the connecting rod when that piston was on the way down on a power stroke. And when it snapped the connecting rod just started dangling around on the crankshaft and started started wobbling around inside of the engine. And that's really bad. And it probably unbalanced the crank, if I had to guess, and then probably snapped more connecting rods here, which is why that piston is sideways in the bore. and it probably destroyed the board, so that's junk. The block's toast. The block's toast. There's not many salvageable parts off of this engine. There are salvageable parts. You could take these pistons off. Crankshaft's probably shot. Crank probably got too hot. That connecting rod probably at one point went up and cracked the piston in half. You could definitely see that you could see that the piston is in pieces down there in that bore. And it probably cracked the piston in half, and the piston probably fell onto the spinning crankshaft, which is about as bad as it sounds. Yeah, that's not good. If I had to guess, this is just me guessing. That's no good. This is fine. That's okay. There is some oil on the head gasket. There shouldn't be oil on the head gasket. But, see, here's what happens. Oil likes to go everywhere. It goes everywhere. That's by design. It's designed to get into small nooks and crannies. You can make something watertight, or you can make it oil-tight. Oil-tight is even crazier than watertight. Because oil will squeeze through everything. So if this piston broke, and that piston broke, there's some scoring on the head gasket right there, and that means that oil is being splashed up these bores, and engine probably overheated, it probably melted the head gasket, and oil started getting in everywhere else. V10s aren't exactly balanced anyway. Yeah, here, let me look. Where's that damn... Ah! It's gone! Dude. It's snapped. The connecting rod is gone. What? How does that even happen? How does that even happen? I've never seen a connecting rod snap down there, AP. And I've never seen a piston uncentered in a bore. How does that even what the hell happened to this motor? Too much evil. I've never seen this. Water in the piston? Yeah, Demon, maybe it hydrolocked. It's possible. I don't see... So the head gasket looks okay. Believe it or not. Except for that one part where I pointed out the scoring, right? Let's go back over here. Yeah. Nah. Okay, so you see this part right here? That's the seal for the head gasket. There's not much of that left. Head gaskets on modern cars are made out of thin sheets of steel that are kind of sandwiched together like a cookie almost. The reason why is that... So they made head gaskets out of like cork back in the day. They made them out of cork. They made them out of felt. Anything. And the thing is that the steel ones are really good. They figured out that steel is the best way because steel has better thermal properties. If the motor gets hot, the steel will expand. And if the motor gets hotter, the steel gasket will expand and seal better. And motors are designed to run at a pretty high temperature, right? So this is an MLS gasket, but I'm wondering what the hell happened here. It looks like somebody either didn't change the oil on this engine from all the carbon residue that's right there. But see, I was gonna say that, but now you see these pistons over here, the ones that are still working correctly, right? Or were still working correctly when the motor stopped, when it grenaded itself. Those don't have a lot of carbon scoring on it, so there's not a lot of carbon buildup, and the bores don't look too bad. I think somebody over-revved this engine. This looks like over-revving to me, but I could be wrong. Like, now I'm looking at this. This is definitely an MLS gasket, but what the hell is all this stuff? What's this blue? Did somebody RTV this gasket on? Like, yeah, you're not supposed to do that because RTV will seal differently than the steel. How you doing? I'm good, Alucard. We got... What the hell is that? What is that? What is that? Well, I don't even know what that is. That's just a chunk of metal. Yeah, the connecting rod went up this bore when the piston was stuck in it at bottom dead center, AP, and it snapped the piston. It obliterated it, and that's why there's a hole in the side of the block, because that piston got dropped onto the crankshaft and shot out the sides. It became a rock polisher. Dude, this is over-revving. This happens when you use too much VTech, yo. That was a joke, please. Okay. So these are your combustion chambers. Note that there's 3 valves. Okay. So this is something that you can learn, and some of this can be transferred if you're into Kerbal, if you're making Kraken tech and stuff. So, okay, they use 3 valves here, all right? So, 2 valves are for, it's 2 valves for intake, right? I should know, I have a motor that's exactly like this. 2 valves are for intake, 1 for exhaust. The reason why they do that, why split the valves? Why not just make a bigger valve? Smaller valves move faster. They can move faster. So the more valves that you have per cylinder, the more, like if the intake valves both open at the same time, right? You can get the same amount of fuel that you could get in there with a bigger valve, but those valves can move quicker, so the engine can rev. This right here is the exhaust valve. Yeah, see, this is intake side, that's exhaust. You know that's the exhaust valve because the exhaust port is right next to it. That's probably... Yeah, these engines can rev up high. And it's an overhead cam engine, so with an overhead cam, so think about this like... think about that like ping in a video game. So if you're from the computer world, you have ping, right? And if you have a higher ping, it takes longer for you to communicate to the server that you're playing on with other people, right? The further away your camshaft is from the valves is a higher ping. So like on older cars, right? On older cars, you have a camshaft that's pushing a lifter, that's pushing a giant metal push rod, that's pushing a rocker arm, and that rocker arm opens and closes the valves. That's called a cam and blocks, or a push rod engine, because you push rods to actuate the valves. There's always a little bit of delay, because you're hitting one thing that hits another thing, that hits another thing, that hits another thing, that hits another thing, that hits the valve, right? So think about it like a freight train. When a freight train accelerates, right, it's going to take a second to get the whole thing moving. It's going to stretch out, right, and then go. In the 80s and the 90s, they figured out that if you put the cam right on top of the head, right, and have the camshaft directly hitting the valves, that if you use smaller valves, they can open and close faster, and you can get more fuel and air in there. More fuel and air you can get in the combustion chamber. Combined with a smaller combustion chamber, you can make more power that way, right? But how do you perfectly get the mixture? Just by controlled valve opening? Well, Alucard, on older engines, they used vacuum as a datum to meter fuel. Yeah, vacuum. Because an engine sucks in air. It creates a vacuum in the intake manifold. And that's basically how a carburetor works. A carburetor, vacuum is being pulled through. Carburetor is basically an hourglass, right, with a fuel reservoir next to it. And then there's a little hole from the fuel reservoir that goes into the venturi. So an engine is breathing. It's going all the time, right? You're breathing in and out really fast. When you're breathing out really, really fast, you get pressure changes inside of the carburetor all the time. And when you get pressure changes inside the carburetor, when the pressure drops, it'll suck fuel through the jets. It's called a carburetor jet. It'll suck fuel through the jets, and it'll bring that air fuel. It'll atomize it because the pressure drops. Because when your intake valve opens and your piston goes down, you're trying to fit the same amount of air in a much higher volume, so the pressure goes down, right? And that's when fuel atomizes, just like a rocket engine. Same thing. It's the same thing, guys. You're just using different oxidizer and different fuel. With a car, you use gasoline and air. With a rocket, you use kerosene and liquid oxygen. The reason why you're using liquid oxygen, one, you need the energy. Rockets have a lot more characteristic energy than a car does. The range is a little bit further. That's the right way to say that. Rockets go a little bit further than a car does, right? Second part of that is that you got to bring your oxidizer with you into space because there's no air up there. You can have a naturally aspirated engine in space. There's no atmosphere to pull from. So you got to bring the oxygen with you, right? And it's easier to bring it as a liquid than it is as a gas, believe it or not. Less volume. So how they control all this, Alucard, is from it was from vacuum gauges back in the day. They used vacuum to meter it. And then you can change the size of the jet if you want to get more fuel, right? In the carburetor, or you could change the carburetor to be able to deliver more fuel, but then you got to make sure you're delivering more air, right? There is an ideal ratio of air to fuel. It's called stoichiometric, or oxidizer to fuel in this case.
RP1 load is complete.
RP1 load is complete, speaking of kerosene. There is an ideal mixture, right, that you can get. It's 14.7 to 1. Give me 1 second, I'm talking to Primo. So 14.7 to 1 is stoichiometric. That gives you the most efficient combustion. You can make the most power that way. Now, the funny thing is, guys, is that the same is true for rocket engines. Rocket engines can run at stoichiometric. The problem is because rocket engines, they put out so much energy so fast. If you run a rocket engine at stoich, it'll melt. Car engines, on the other hand, because, a piston has an explosion once every, 2 movements of the piston. So up, down, explosion, up, down, explosion, up, down, explosion, right? It's not all the time. You can run stoich and the thing won't overheat. Cars also have a radiator. It's hard to have a radiator with a rocket. You have to shut off a lot of heat. Cars don't generate as much heat because they're not making as much power as a rocket engine does. And I'm talking about power in terms of energy consumed. In terms of energy that the thing puts out. A car engine is like a Hot Wheels car comparatively to a rocket. It's nothing. Stoich like a tiger. Coincidence that sea level atmosphere is 14.7 psi? I think not. Yeah, exactly. That's why it's 14.7 to 1, right? Rocket engines can't run stoichiometric. In fact, a lot of rocket engines run extremely fuel rich. Shuttle motor, shuttle engine. They run extremely fuel rich for cooling. True story. That's why the shuttle is a fuel rich stage combustion cycle. On the other side of that, you have engines like the BE4, RD180, RD170. Those are oxygen rich. The reason why those things are oxygen rich is because you want to get the most efficiency out. You deliver way more oxidizer than you do fuel. Well, all that fuel is going to combust, and then you're going to have leftover oxidizer coming out the bottom, right? That gives you the most energetic burn. It's not very efficient, but it gives you the most energetic burn. So, oxidizer rich is called lean, and it's not oxidizer rich. It's just lean and rich. That's what you have, and then you have stoich in the center. And it really depends. It really depends on what you're doing. But yeah, the fuel mixture was metered by vacuum. Alucard. You prefer the vacuum option now? Well, the vacuum option is simpler. It's way simpler. Way simpler. You don't need a computer for it. It just uses physics. Physics is the computer that governs the motor. Right? Because they didn't have computers at the time. Now, everything is controlled by airflow sensors. So, on most modern cars, you have what's called an MAF. You have a mass airflow sensor. It's basically a pitot sensor, like on an airplane. It's a pitot sensor that's inside of your intake on your car. And that airspeed information, the airspeed that data is being sent to the computer, and then the computer will deliver the right amount of fuel to get the ratio correct. Now, when you have a computer controlling it, Alucard, the computer can basically make slight adjustments. It'll make slight adjustments through what's called a fuel map to make sure that it's delivering the right amount of fuel at all revs. So it's way more efficient. That's why modern cars, even like a V10, this V10 that we're looking at here, the V10 has, we got to get ready. Falcon 9's going to launch in a second. That V10 is like a 6.6. Okay, prop load has started. That V10 can get better gas mileage than like a 4-banger from back in the day. That's why, because the computer's controlling it. Now, the thing about it is that some automotive computers nowadays are dynamic. They're self-learning. So it's like a very primitive neural net that learns what the most optimum amount of fuel is over time. They learn. It's very basic learning. It's like, It's very basic neural net stuff. Like they teach themselves the fuel map over time. But most fuel maps on cars nowadays are actually baked fuel maps. So they, through the testing from the factory, the people would say like, okay, we're going to program it to deliver this much fuel at 4,000 RPM, this much fuel at 4,500, this much fuel at 5,000, 5,500, etc., etc. And that code is loaded into the computer from the factory, and it'll just follow the code. Very basic.